Alright guys, today we're going to be talking about vectors, and we see vectors all the time, especially like for example in this picture of a GPS. We see an arrow and we see it's going somewhere. So a plane, a boat, or a car cannot go to its destination unless we have direction and distance. So a vector quantity is just that. It has to have a direction and a quantity or a number. In other words, a vector has both magnitude and direction. Magnitude means number. It tells you how big something is, and direction is which way. So magnitude and direction, you need both things for vectors. So what does magnitude mean? It is the size of something, no direction. Magnitude is a number, a value. So some examples of vectors. So we have magnitudes here. The magnitudes are 3, 7, and 10. That tells me how much or how large. North, south, and northwest are my direction. So I have a magnitude and direction, so that means I have vectors here. 3 meters north, 7 blocks south, 10 miles per hour northwest. Scalar has magnitude only. It tells you how much. So when we say it's a scalar value, it's only telling me a number value. Some examples of scalars. So like 5 meter, 40 miles per hour. So these things are things that have a number and perhaps a unit. That would be scalar. So let's look at some practice here. So let's determine whether something is scalar or vector. So for example, the first one, 5 miles. Well, I have a number, so I know that's the magnitude. So that's magnitude is 5. And the direction, well, it tells me the amount, it tells me 5 miles, but it doesn't tell me direction. None. So therefore, this would be a scalar quantity. Okay, let's try one more. 13 meters per second southwest. So I have a magnitude of 13, a value, and I have a direction, southwest. So if I have magnitude and direction, that is going to be a vector quantity. You can pause this video and see if you can do the rest of the problems by yourself, and then you can check. Next, we have a magnitude of 9.8, and we do have a direction. It is down, moving down, so that is a vector. Next, my magnitude is 27 feet, but it doesn't tell me direction, so there is no direction, so that is only scalar. 5 miles, 30 degrees northeast, that definitely has magnitude and definitely has direction, specifically 30 degrees, but northeast, that's the important part here. So that means that's a vector. So now when you look at a GPS, you might look at it a little bit differently now that we learned vectors and scalars. So for example, down here where it says 80 meters, well, we have a scalar quantity, but we also have a direction. It's telling me to go to the right. So have you ever used a GPS device? Direction is always important when describing motion. So how could you get, let's say, to Charlie's Tacos? Or if you're watching this video from somewhere else, how would you describe to somebody how to get to a different place? So let's say that this is a way to Charlie's Tacos or any other place. So we go from point A to point B, and that is my distance. So distance is a scalar quantity. It's going to tell me just how much I need to cover. So for example, 10 miles, 5 feet. So distance is the actual path all throughout. So what if you could super jump to that location from A to B? Okay, so you're kind of skipping all that distance. Now this is called displacement. Displacement is a vector quantity. It's an object's overall change in position. So not only am I telling you the number, I'm also showing you the way. So displacement is the shortest path from point A to point B. A vector can be represented with an arrow. The length of the arrow shows the magnitude of the vector. So for example, the arrow on the left has a greater magnitude than the arrow on the right. Displacement vectors, they describe the change in position, and they have units of distance. So suppose you walk 5 meters east, you turn, go 8 meters north, then turn and go 3 meters west. Where are you relative to your starting point? In order to answer that question, we see that we have individual displacement vectors called components. We said we went 5 meters east towards the right, 8 meters north towards the top, and 3 meters west towards the left. So if we put the vectors together as in the picture, we can see that it starts forming a picture that we can work with. Adding vectors. So when we add vectors, we're looking for either distance or displacement. If you're looking for distance, then we can just add the components. This is the easy part. So what would be the distance in this scenario? So to get distance, we just add them together. So 5 plus 8, 9, 10, 11, 12, 13, plus 3 equals 16 meters total. That's how far they went. The resultant is the sum of 2 or more vector components. So this represents our displacement. Remember, this is like our Superman jump, our shortcut from point A to point B. So let's say you walk 4 meters east and then 3 meters north. What would your displacement be? Okay, remember displacement also has direction. So in order to answer that question, we look at the Pythagorean theorem and see if we can form some type of triangle to solve this problem. So in our problem, we said that we go 3 north and we go 4 east, and then we're trying to find this side, or C in our case. So we just use Pythagorean theorem. So we have 3 squared plus 4 squared equals C squared. 3 squared is 9 plus 4 squared is 16 equals C squared. This is 25 equals C squared. So then we square root both sides to get C by itself. C is equal to 5, but that's not our final answer. We're trying to look for displacement. So we say 5 meters towards northeast.